Good evening to all. Today we can discuss the topic of implementation using NAND gates in the subject Digital Principles and System Design. I am Dr. S.T. Himlin Rose, Assistant Professor, Department of BCE, RMD Engineering College. So the implementation using NAND gates will have various steps. So there are commonly we have 5 steps. So the first step is draw the normal form, that is your AND or invert basic gates. Using this, you have to draw the logic function for the given function. You have to draw the given expression using the gates. Okay. The second one should be add bubble on input of OR gate and output of AND gate. So to the input of OR gate and output of AND gate, you have to add bubble. Third step is add an inverter. So we have added bubbles and we have to add wherever you have updated with the bubbles, you have to add an inverter on each line that is used with the bubble. Then fourth step, eliminate. So we have, for example, we have double inverter. Double times we have inserted bubble means we will be using double inverter. So eliminate all the double inversions. And the fifth step is you have to normally replace, after replacing all these double inversions, draw all gates using NAND symbol. So these are the various steps. So these like this, you have to replace everything, or you have to replace. For example, single means you have to replace like this. So these are the steps. So first step, draw the AND or invert logic for the given function. Second one, we have to add bubble on input side of OR gate and output side of AND gate. Then third one, we have to add inverter on each line we have used inserted with the bubble. And fourth step, eliminate all the double inversions. And the fifth step is draw all gates into a NAND symbol. So we can see with an example. So the question is, implement the following Boolean function with NAND gates. So the given function is f of 3 variable function 3x, y, z. So summation of 1, 2, 3, 4, 5 and 7. This is the question. So you have to use with the 3 variable means the three variable gamma. So that how many terms you can get for 8 terms. So you have to use x, y, z. So here it is 0, 0, 0, 1, 1, 1, 1, 0. Then here it is 0 and 1. So, you know the logic already. For 0, 0, 0 to 0, 0, 1 to 1, 1, 1. It should be 0 to 7. So first 0, 0, 0, 0, 1. 1 means 0, 0, 1. So it should be 1. Then 2 means 0, 1, 0. So it should be 1. And 3 means 0, 1, 1. It should be 1. And 4 represents in binary form 100, so it should be 1. And 5 it represents 101, so it should be 1. Then the last 7 should be 111, so it should be 1. The remaining two terms 0. So how to combine? We have the possible. We have to combine all the ones. So 4 combine maximum logic with 4. And the next combination should be we can have here as this 111, and the next combination we can have it as 111. So what is the function f of x comma y comma is equal to, for the first one here it represents bar. So it is x bar, sorry, x, and here this 0 and 1 gets complemented. So for y it is 0. So for z it is complemented. So y it represents y bar plus, for the second case, this one should be 0. So it is x bar. Here this 1 and 0 gets complemented. So this 1 represents y. Then for the last, combined all the terms, this 2 gets cancelled out for this 1, 1, 1, 1 combination. Here, this 0 and 1 gets complemented. So only 1 is present, that represents Z. So this is your Boolean expression for the reduction, using the reduction of theme. Now we have to implement it using the logic gate. So your step 1 is you have to draw the given expression, Boolean expression with your normal gates. So first x, y bar. So we have x, then x bar, then y, y bar, 3 variables. Then z, you don't have any. So we can have. So first is x, y bar. So x, y bar, it is and then x bar. So x bar represents this one. Then y. So this is x y bar. This is x bar y. Then this one is z. All should be all together. So all together. This will be form your f of x comma y comma z. This is your step 1 for the implementation of logic. Step 2 is you have to add bubbles to the input of OR gate and output of OR gate and output of NAND gate. So first one, this is your NAND gate. So you have to add bubble. This one is your inverter. Here you have Y. Yes. Y. Then Y bar. So this X bar and your so here you have one. You have to add bubbles over here. The resets. Okay, we have added all bubbles. Now input to the OR gate, you have add bubbles. We have add bubbles. This is the step 2. Okay. Now, wherever you have given bubbles, you have to go for which one? This inversion. So, inverter. So, here you have added one bubble. So, what are the positions where you have to give inverter? Let's see. So, here you will be having a bubble. So, inverter. Here you are having a bubble inverter. Here you are having a bubble inverter. So, here you are having a bubble inverter. Here you have one inverter. So, these are the positions where you have to add inverters. So, first, AX. So, you have to add an inverter here. You have to add an inverter here for the first bubble. Next, you have EZ. Okay. Now, come to this point. This OR gate. Here we have added 3 bubbles. So, for this, you have to add an inverter. And for this bubble, you have to add an inverter. And for this bubble, you have to add an inverter. So, now it becomes the third step. You have added bubbles to all the places where you have given the you have added inverters to all the places where you have given bubbles. Step 4 is you have to eliminate all the double inversions. So, in this position, in this location, how many places we are having double inversions? So, this is one double inversion. This is one double inversion. So, you have to eliminate it. This is one double inversion that you have to eliminate. Remaining all will exist as the same. Okay. So remaining all we have to extra as it is. So yes. So if we have eliminated the double inversion, here you have one inverter. So this is your step 4. Okay. So all the double inverters are replaced. Only one inverter present is the existing. Step 5, you have to replace all the gates with your normal NAND symbol. Okay. So step 5, you have to replace all the things with your normal NAND symbol. So first, this is already NAND. So this will be as it is. Then this is H. From this H bar you will be having. So that also replaced it. So but it will be doubled because we have clubbed together, right? Then Y bar. So that also replaced by an NAND gate. Then Y. Again, this will be an NAND gate. Then Z, there is a inverter that also combined together will be changed as a NAND gate. Then again, we have given the OR function that also combinedly converted to be the NAND gate, which will be use the function of f, x, y, z. So all the gates are now replaced with AND gates. So these are the steps to be followed for implementation of NAND gates. So I will summarize the steps once. First step, for the given example, what we have do is, for the step 1, we have drawn the normal logic using AND or invert. So AND or invert, we can call it as AOI form. This is your normal form. Step 1. Step 2, what we have do is, we have given bubbles at the output of AND gate and the input of OR gate. For all the gates, we have did this. Third step, wherever we have given bubbles, we have added inverters. So here add inverters, 2 bubbles, here 2 bubbles, here 1 bubble, so inverter. Now double invert, step 4, double inversion should be eliminated. So double inversions are eliminated. Only this one will be present apart from the normal gates. Now replace all the gates with your NAND symbol. Will give you a NAND implementation of that particular function using your NAND gates. So hope you have understand well this one. Thank you.